Alrighty. Okay. I know there's a lot of excitement there in the back with gaming the system. Indeed. All right, Mr. Google. All right, let's go. Well, it is my distinct pleasure to open our lightning talks. And actually, I'm not, he wasn't kidding. We did run these names through MD5, and they came out in the same order. Last is Robert Shadek. His MD5 starts with 2 Fs. Loser. Right. He's got like a 2 in the front. He's good. So, and I entered, by the way, I entered the diacritics too. So the C with Sedil is there. And Dragoș too, my fellow Romanian. Okay, so we're going to have Ali now. And we have like 5 lightning talks. Each is going to take 10 minutes. And just take it away.
All right, let's see. 26 slides in 5 minutes. You won't be able to sleep. So this is about assumptions. But first, I have an off-topic slide. This is a bonus slide after Walter Bright's presentation. He said, don't make strings and return them. Put them into output ranges. The first function here is the slow version of the toString member function because it returned a string. Instead of doing that, do the ugly version. That's the fast one. Because there's only one string ultimately created at the end, all the call tree of 2 strings will fill into that buffer, and you won't be stressing the GC. And there's a shameless plug to a website where this example appears in a wider context. So now, why this talk? First of all, there was a slot in the lightning talks, and I wanted to get in there. Then function for performance. And graphing for assume under Phobos std finds other interesting functions. So I tied them all together. They are loosely related other than the fact that the names begin with assume. And the most interesting thing is, being software engineers, we know that assumptions are bad. They've been the cause of all these horrible accidents and disasters. The first one, I'm sure Amaury knows what it is, etc. So that's a bad thing. But we have these assume functions, and this is the real reason why I'm here. Is Andre here right now? No. All right, assumptions are dangerous, and there are so many quotes on the website that you can find. I made up the second one. However, assumptions are everywhere. In our daily lives, we live with assumptions. Everything is an assumption, and we programmers do these about the requirements, about the design decisions, the program's environment, behavior of code, even APIs. If something looks like a familiar function to me, I assume it will act the same way in another library, but sometimes they are not. And there's just an assumption that we all do, and the link that I've given before also makes this assumption that readf will work correctly, or will read data. But the second version validates that assumption, and that readf actually read one item. The D programming language is adamant about validating assumptions, and we have all these cool tools. Assert, preferably in those contexts, and enforce, preferably in those contexts. So these are great, and exceptions are great because they really validate your assumptions. If an exception is thrown, you know you're not going to the next line. They stop you there. Okay, the rest of the talk is a collection of examples of formalized assumptions is what I called, because if you make a function out of your assumption and put it in a library, it becomes formalized. So it seems legal to do. Okay, here's an issue. Searching is linear by default. Standard algorithm has these awesome functions like find split, find adjacent, and many more, but they are general functions. They work with input ranges, and no input range, well, input ranges are not random access, so all these functions must do linear searching. That's why they are all big O of n, have algorithmic complexity of O of n. However, the same module, standard algorithm, produces a special type called sorted range, which lives in standard range. So if I say on the first line, ARR sort, it returns this object, an object of sorted range, which has these special functions where give you O of log n complexity. Because array is sorted, the return type knows, oh, I can use binary search with interesting access patterns with maybe on the next slide you'll see with gallop, trot, or different. And sometimes we can put this sort into a UFCS chain like this, foo bar sort and contains 42. Because sort returns an object which knows the range is sorted, it is O of log n. So what is sorted when you say sort? ARR is sorted. And it is sorted in place, but the return sorted represents that ARR in a very thin wrapper. It's a very thin wrapper. However, the can-find algorithm in the standard algorithm module doesn't know about the fact that ARR is sorted. So if you do ARR can-find 5, it is still O of n. But if you do sorted contains 5, you get O of log n complexity. So that's fast. So don't do this. Don't say ARR.sort and throw away the returned wrapper, because you will be have to do contains 5 and you're unnecessarily in O of n now. You've thrown away your information about being sorted. And one problem you may face is you already have a range that is sorted. So IOTA there is producing sorted range, and then the map I apply to it necessarily produces a sorted range. But if I go ahead and say, let me use it as a sorted range and get trisect of it for the number 6, it doesn't even compile. So the solution is assume sorted. Assume sorted lets you tell to the module that assume that this is sorted, and magically you get O of log n complexity now from it. And if you're curious what trisect is, it is a great, very optimal function. It gives you where the found range is and the before that range and after range at that range in O of log n complexity. Also look at this enum, which enables you to fine-tune the search algorithm. Another issue, when you work with slices, only one overlapping slice has capacity. Look at the first line. I created an array of 8 items, and then I produce 3 slices out of it, as in this picture. 8 zeros, some extra capacity will be allocated already. 3 slices providing access to it. The problem is only one of them has that capacity available to it. The other 2 cannot stomp elements of the other 2, so they have capacity 0. This is great. The data is protected. But then the problem is it is so easy to lose that capacity. Look at that function. It creates a scratch array, the first 8 elements, plays with it, then returns a slice of that original one. Since the slice is shorter than the original one, when you return the slice, you lose your capacity. Not good. Even though you have only one slice returned from that array, you lost your capacity. So put an assume safe append at the end of that returned slice. Assume safe append means I'm transferring the capacity to this slice. Now we are happy. The returned slice has capacity. There's a problem with array. Steve Schweighofer and Monarch Dodra knows about this. We talked about this. But this problem will go away, and array will return slices with capacity in the future. Another issue is using mutable as immutable. This is from an old topic already, from DConf 2013. A function needs immutable. I have mutable data. I can't give it to it. Lesser solutions would be copying the data, which is slow, or casting the data, which is unsafe because later on in this context, I may modify what I promised to be immutable. Semi-safe solution is to use assume unique. What you do is, my array, assume it is unique so it can be passed to a function that can take immutable. But there may be other slices that mutate that data. That's bad. So prefer this method. Put maybe make a local function, return your mutable slice, put a pure at the end of the function. It again works. That's a good solution. Another issue, your no-throw function may need to call a yes-throw function. So it doesn't make sense. The compiler doesn't let you do this because foo is no-throw, bar is yes-throw. However, you know that bar 7 does not throw because bar throws if enforces that I is less than 10 and it's happy.
1 minute, Professor.
Thanks. So hand crafted solution would be put everything into a try-catch block, catch everything, and the compiler lets you do that. Now it compiles. But it's not safe because in the future, after maintenance, your bar 7 may start throwing. So you have to create an error and throw that error yourself. Or forget about this solution and just go use assume won't throw. What you do is assume won't throw bar 7. It will actually wrap it in a try-catch block, let you call that. However, don't do this. This is a confusion. It looks like a UFCS chain, and you may think bar 7 executes first, and then assume won't throw operates on its result. Not so. Assume won't throw takes a lazy range, and this is that thing, lazy expression. That's this expression. Even though this is confusing, that actually does that. Don't do this. Just going very quickly, it's 23. Sorry, guys. So your pure function may need to call an impure function. This solution doesn't work. There's no cast pure. The solution is by David Nodlinger in a function comment in Phobos. Apparently, we have this function attribute pure, and you can make set function attributes. So just do that. Assume pure, and now you're allowed to call. Last slide. Thank you very much.
Thanks. Fantastic. I didn't know a few of those things. So next is Attila, who apparently has one more thing to say. I think we should add to the standard library a function called assume correct. Just work. Assume it works. We should bring Adam up for some more jokes. He was like the stand-up comedian doing a tech talk. Pretty amazing. Right, I know the title already. Development with Emacs.
Okay, I mentioned this to a few people during the conference, and they said that maybe other people might be interested in it. So I just want to show a few things I do with development in Emacs. I'm an Emacs user, as is obvious by the title of the talk. If you're also an Emacs user, then you might find this useful. If you're not an Emacs user, then you're a heretic and you're going to hell anyway. So there's that. Okay, so fly check. This is a very cool Emacs package. It's not totally related to D, but I recommend you install it. what it lets you do is it's on-the-fly syntax checking for Emacs. So as you're typing, it calls off either an interpreter or compiler in the background for you, and uses that interpreter compiler. It calls it checkers because it depends on the thing it's actually running. It could be a linter as well. And then it parses the results and it highlights whatever errors you may have. So if you have a variable you're not using, it might have a little question mark next to it. And you get the errors from the compiler. So I recommend you install this for any other language. For Python, for instance, the checkers it supports is Flake8 and PyLint, and it's actually pretty cool because the one it calls, it has a priority list, and if you have Flake8 installed, it calls it. If you don't, it calls PyLint. They added somebody added D support to it sometime around last year because I was editing decode in Emacs and suddenly things started getting highlighted. I went, that's cool. But there's some problems with that, which I'll show you in a bit. So I did a pull request to FlyCheck so that it could support passing -i flags to DMD so that you could tell DMD where to find the modules that you're going to be importing. After that, I wrote this package called FlyCheck DMD dub. Now, what this guy does is, well, first of all, it's an Emacs package in Melpa as well. So if you want to install it in Emacs, all you have to do is fire up the package management, and you search for it and install it, and it'll just work. Well, there's one more line you need to add to your Emacs configuration, but it's up there on the GitHub page. So what the package does is it uses Emacs lists to parse the JSON data from dub. So basically, this is for dub projects, which is common enough in the D world, obviously. So if you have a dub project and you have dependencies, what would happen before this was it couldn't find your dependencies because it doesn't know where they are. So the first thing you get is a highlight, cannot find your import, and then the on-the-fly checking doesn't work anymore. So unless you're using a toy project or you use that thing from my pull request before, which you need to do manually, things don't really work. So basically what this adds is support for dub projects. It asks dub itself for the dependencies and then passes those dependencies to DMD with the -i flags. Now everything works. So basically if you install these two packages, you get zero config as you type syntax checking for dub projects. So nothing else needs to be done. You open a dub project and things work. And the other thing I just wanted to mention is other things that you can do. Auto-completion, we saw that yesterday. I still have to try DCD. I know. It's my fault I haven't done it yet, but I will soon. Okay, and then you can compile and debug from within Emacs too, but I'm not going to really touch on that. So what I wanted to show you is, here's obviously Emacs, here's a D program. It's not very interesting, and that's on purpose because I just wrote it after lunch. And, you know, there's nothing highlighted. It shouldn't be, because why would there be? Now, if I click over here and add the G, then this thing gets highlighted with red because it doesn't compile anymore. Now, unfortunately for us, the screen is kind of falling off the edge, but at the bottom it says, no property get string for type hello world, did you mean get string? Okay? So if you delete the thing again, and so it doesn't call the compiler that often. I'm not entirely sure what the algorithm is. It's often enough so you don't have to worry about it, but not so often that it kills performance. However, this is just some random project I have here, which isn't, you know, that important or anything like that. If I try importing anything else, like say vibe.d, then it's not going to find it. And there's no reason for it to find it. Now, if I switch from this thing here to another project that is using dub, which is this guy, it's, you know, not very complicated, just using my serializer library that I mentioned in my talk on Wednesday. Sorry about that. Just to show you the dub.json, here you go. The dependencies are serialed. Is that thing on the screen? Yes. So I've listed serial as one of the dependencies. It finds it automatically, and that's why. If I could type faster. If I show, okay. If I go back to here, there's no errors again because it can find it. However, if I add an S to bytes, again it starts highlighting it because I've made a mistake. So I get on the fly syntax checking. And to prove to you guys that this works. If I try importing vibe.d again, then it's not going to find it because I didn't list it as a dependency. So that's pretty much what I want to show. If you use dub projects and you're not a heretic and you use Emacs, then you can use this. That's me.
Great, thanks. I use Emacs and I'm going to use this stuff. All right, Brian is next with a project we're already using at Facebook. Oh, sorry, it's your other project, which we will use.
Is this on? Oh. Okay, so we had the last thing D needs. Now we have two of them, the last things D needs. So where are we right now? Where is this right now? Unplugged. Okay, so right now we have a really awesome samurai sword with a machine gun in it. That's our language. We've got D. It's awesome. So what do we do now? Well, the answer to that question from almost everybody is we need more tooling. So that's what I've been working on. So for those of you who don't know, I'm Brian Schott. I'm the author of the DCD and DScanner projects. You might have heard of them from the other talks earlier. So what is DScanner? So it's kind of my testbed application for a lexer parser and AST for D in D. It has a few features that if you use C tags, it will generate C tags files for you that actually work. If you need it, it will generate an AST dump of a D source file in XML. You can do whatever you want with that. It will highlight your code into HTML format. Syntax checking because it has a parser in it. Line of code count that's a bit more accurate because it actually is a tokenizer. You can tell it to list all of your imports in a file. It'll do that. And then this is what I've been working on recently, adding a bit of static analysis checking. So DCD is a project that got spun off from DScanner a while back. It's a IDE-independent auto-completion. Instead of putting, trying to get Vim key bindings into your IDE, why don't you just take the autocomplete and put it in Vim? So that has integration scripts and plugins for several text editors. TextEdit, which is the one that I use. There's a Kate and Kdevelop plugin called Lumen, which I think was demonstrated already. Vim, Sublime Text, Zeus, and Emacs, though I haven't gotten a pull request for the Emacs recently. So if you're using that and you know how to actually write scripting for Emacs, let me know. Need your help. So here's just a screenshot, autocomplete in Vim, and TextEdit. So static analysis, why do we need this? Well, I think this sums it up pretty well. If the compiler accepts it, it will be in your code base. It will get there. I don't know how. It'll be there. So what kind of stuff do we want to look for? Well, stupid things like this. Why is that if statement there? No idea. How about this? Are you initializing that struct member, or are you doing absolutely nothing? Be nice to know. How about this? Does that default value do anything? Can you have a zero argument struct constructor? No. Should probably have a tool that tells you that that's completely pointless. How about op equals? Should that ever not be const? Should you ever modify something while comparing it? No. Is that a yes? Okay. All right, how many times does that for each loop execute? 0. It doesn't go backwards. It just doesn't go at all. How about this one? That one explodes. Might be nice to know that before you actually compile and run, especially if it's hidden deep down somewhere in your code that doesn't execute for a while. Now, how about this? This is the most recently added feature. Did you actually mean to write the x coordinate twice? Probably not. What does z coord do? Nothing. It does nothing. How about y coord? Nothing. Completely unused. So DScanner will check for this stuff right now. The code is on GitHub. So why did it take me so long to get to this point? Because I was working on this stuff DConf last year. So there are a few problems with developing tooling support for D. There's the essential complexity, just part of the language. If you have mixins, you have CTFE that then goes into mixins. If you have auto, op dispatch, all that stuff, autocomplete is hard. So the only way to really do this properly is have a full compiler, your compiler front end actually providing your autocomplete. But there's way too much accidental complexity. So here's a listing of things that the language spec does not agree with. I gotta check my timer there. Okay, like grammar specification says that if you have contracts on a function, you have to have a body. And then another part of the language specification says if that's an interface, that's not true. So let's talk about D. So 1.a, 3 tokens, a.b is 3 tokens. However, if you add a space, 1 dot space a is 2 tokens, and a dot space b is 3 tokens. Sure. Okay. Of course, with the slice expression, you need to do look ahead in your lexer, figure out what in the world's going on. And my lexer for D, I've got seven different string lexing functions because string. I don't know if anyone here, like if everyone knows what a here doc string literal is. Just a quick show of hands, how many? Okay, so roughly half. They're terrible, don't use them. Okay, occasionally when we get to de-improvement proposal, we end up with bonus features. Like there's the feature we intended to introduce with the DIP 42. Sorry. So we're supposed to add this first syntax, enum. What we also got was the other 3 and a few others that I didn't bother to put on the slide because you get the point. Welcome to Whose Language Is Anyway, where the grammar is made up and the keywords don't matter. All right, so here's a slide containing things that the compiler accepts. And it scares me. Can you even pronounce that without getting your tongue tied? Okay, so one of the good things about D is consistency. You've got if and static if. Pretty much the same thing. See? If, parentheses, statement, else, colon, right line. What? Okay. But yeah, that part does not compile. The top does. That's valid. Where in the language specification it says that's valid, no idea. All right, so what's the right way to declare a template class? What? Which one of these is correct? Is the top one correct or is the bottom one correct? The answer is yes. All right, unit tests, no parentheses. Invariant, yes. You do need parentheses there. Why? For consistency. Okay, so here we've got an array. So what does the first one do? 0 slice 0. It's empty range. All right, so what does the second one do? Range error. That actually dies at runtime. What does the third one do? Empty range. Sure, why not? Okay, so one of the great things about D is its compatibility with C. We've heard that several times. So D has a way of declaring arrays, and C has its way. So D also supports the C way, except that it doesn't. If you try doing this, the compiler will helpfully tell you that array of int and array of int are not the same type. Can we please kill this syntax? Please? We don't support it, and we don't not support it. Okay, here's a fun one. You can have a catch statement with no actual exception named. So catch and then a statement. Is anything wrong with this? Right, okay, ignore these missing semicolons because I'm an idiot. Actually, the problem here is that the parser doesn't look to see if it's actually a statement. It just looks for the parentheses. So a standard error is an exception, which raises the question, don't exceptions have to have names? The language specification says yes. The compiler says no. You can do this.
30 seconds, damn it.
Somebody doesn't like me up here. Okay, so let's go the other way. We take the grammar specification and try to build code off of it, and you end up with that. Oh well. So anyways, yeah, links to the code. So we've got the D grammar specification, which I think is a bit more accurate than the official one. DCD, the autocomplete engine, dscanner, and then that one there is the listing of the tracker bug, and it tracks all of the other bugs that have been filed against the language specification. And I've run out of time.
All right. This is fantastic. Not sure if I should laugh or cry here. When I collected the numbers for my opening talk, I was like, you know what? Whatever the numbers are, I'm going to show them, even if it hurts. Numbers didn't come out so bad. So I was like, oh, maybe I'm going to get away with this. The time of reckoning has come. Okay, next is Dragoș Karp, a fellow Romanian living in Germany. Just to kind of introduce him a bit, if you go to Germany, do not take the subway.
And probably you know why, because last year there was a talk about this. So I became aware that there is a company in Munich that is using D. I applied to this company. The next day the talk was published, and then here I am working for this company, and this time seeing the DConf live. So I will use this opportunity to say a couple of words about the company I'm working for. So we are based in Munich. We really do application development in D2. We have a decent code size in D, 280,000 lines of code. So about our experience with D, actually we are very happy with the productivity. We really test every beta version and report the regressions. I think they are really with every release better. We have a lot of unit tests. Because of this, we can easily find these regressions. We use the unit. I think probably 30% of our code is unit testing. And then recently we are also using dmocks for mocking. We love the contracts. We don't disable them in the release version. And we also love the unified function call syntax. But there are some annoyances. We are still using some Tango libraries in D2. And especially it is annoying because, for example, for logging, there are some competing solutions for this, but we are not sure what will win. maybe the standard experimental will help in this direction. Okay, now I'll go to the to my topic. So I used CMake in the last 6-7 years, and not the actual company, but before I found it very useful for C++ projects, and we also have some products where we have both C and D source codes in the same project. And I thought maybe it's interesting, if you have a C project and you want to port it to D, maybe it's useful to mix them. And a little overview about CMake. It's really useful for cross-platform and for cross-compiling, maybe for the ARM processor will be very useful. It supports out of 3 builds. Unfortunately, it's an ugly scripting language, but it's really useful. How many of you is using CMake? Okay, not so many, about 20%. Okay, but it's regularly updated and good maintained. I think there is somebody now working to bring D support, native support in CMake, but the problem is at the moment that with this solution we will need to recompile CMake. What I did, I found the CMake adaptations for D and did this that it is not necessary anymore to recompile CMake or to install this adaptation into the system path, because this is sometimes not so doable. Actually, it's a very, very small trick for this. So how CMake is working, you have the CMake project, and then the CMake generates the make file, or Ninja also. It caches the settings, because you can say, oh, I want to generate the make files for release, or I want to, you really can customize your build. And then you call make and you get the executable. And a nice bonus, it also generates the workspace or the project files for this. But what to do if you have a dub dependency? And this is the adaptation that I did. So what is necessary for this? You specify the dub dependency. You check if this is right in dub. You download it. You parse this JSON file. Then you download the. This is the description of the package. Then you download the source code of the dependency, and then you need to convert the JSON to CMake. We are working here with CMake, so we want to convert that. So how do you do that? The first one is easy. You simply download the JSON file from the dub registry. The second one, I don't know. There is no JSON support in CMake. The download part, it's also easy in CMake. You simply write external project add, download. You specify where you want to download it and from where, and then you can also apply a patch, and this patch will be to convert the JSON to CMake. As I said, the syntax is ugly, but very useful. In 5 lines, you get all this stuff. And about parsing the JSON, I thought, if you have a D project, then why not using the D compiler, and because D has some nice useful batteries included. So I wrote 2 programs, one that parsed the package description, and then another one that converts this JSON to CMake. So yeah, that's it actually. So how it looks like? Actually, you have you need to include into the CMake project 2 lines of code. One is to say I want to use the use dub package, and then you simply say add a dub project. How is this called, and which version or version range? Yeah.
30 seconds.
So it's not necessary to recompile CMake or to install this adaptation into the system part, and yeah, you call it like this, and the source code for this you find it on the link. So now I'm ready in time.
Awesome, thank you, Dragoș. Last but not least, Robert Shadek, should I say? Don't mind his MD5.
Yeah. So apparently logging is in still high demand, and hopefully I'm at the right spot right now. Yeah, state-of-the-art logging indeed pretty much looks like either write-ln with a line in the file and then your message, or some homebrew solutions, or using like legacy stuff from Tango. And there also has been a previous attempt to get logging into Phobos, which kind of died like a year ago or a year and a half ago. So and usually I find myself the first thing I write is copy some functions which brings me basic logging to my projects. And after a while, I found it kind of annoying, and so I started my work on STD Logger and got it into a pull request, and yeah. So the requirements are, at one end, I wanted to have it very, very easy. So the only things I wanted to write to get the logger running was basically write import STD Logger and then log. I didn't want to hassle with any log levels or whatever, but I pretty soon realized that this would probably not work on a greater scale. So what is also required is it should be very easy to configure, and it also has to be extremely powerful. So imagine if you have 280,000 lines of code, this wouldn't really scale. So, but the configuration is kind of tricky, because you can't really create that configuration file, because as soon as you think you have your configuration file done, somebody comes up and says, I want my log message to be logged if it's a Thursday and it's raining and a red unicorn is running by, which you probably can't describe in your log file or in your configuration format. And having a specific datetime format isn't really that difficult, but still it would add a lot of code into the logger, and you probably would fail by parsing whatever people put in there, especially as we apparently kind of fail by parsing D itself. So yeah, and then I thought maybe I should take a step back and do it in a very simple approach, and there I came back to thinking, well, D has classes. Why don't you use object orientation to basically do, or let the user do what he needs, and then just provide a simple, easy interface on how to use the logger. So the current approach is basically you subclass the abstract logger and write a write log message function or method, which just take the payload from the actual log function implementations from the abstract logger. And then you're basically set. You have a function, you have all the data you probably want to have, and you can do whatever you want, really everything. And then whenever somebody is saying, well, I want to have this configuration format, and do really, really crazy stuff and want to log to some file system which only accepts whatnot, you say, yeah, I don't know what you're talking about, do it yourself. And then he can still use that, and if he comes to census and try to use something more like commonly used, he can simply instantiate a new logger with whatever is more appropriate now, and he doesn't really have to change anything to the interface. So currently, there are a couple of loggers available, and the simplest one is simply logging to the std out. And you can either use warnf, which is using the default global logger, but you can also use the logger directly, as shown in the second and third line. And of course, there's a printf logging facility, because quite often you find yourself trying to log in a like printf style manner. So right now we have the stdio logger, which basically logs to your terminal. We have a file logger, which logs to file. And then to request, we have a null logger, which does nothing. It doesn't, like, really nothing. It's like the most boring class I ever wrote. And also we have the multi-logger. And the multi-logger is quite interesting, because one of the requirements, or one of the early posts in the news group about the logger was that I want to have some kind of messy hierarchy with multiple stages, trees, and whatnot. And again, I found myself thinking how to actually do this and make everybody happy, but on the same side, don't really try to make everybody happy. And so then again, I looked at D and found that associative arrays are just like really what I want. I want to have a name and I want to have a logger. And if the logger is abstract, I can basically put whatever logger I have in the associative array, also multi-logger, which then will give me like the next level in the tree. And so yeah, multi-logger is basically just also a very boring logger within associative array, which maps strings to loggers. Done, basically. You can do whatever you want. And then the multi-logger implementation of write log message is just send it to all its children. And this turtles down all the way of the tree you probably built or didn't build or whatever. I don't care. Yeah, and also one of the early discussions were that people had different ideas of what kind of log levels are needed. So I'm pretty sure if we ask every person here in this room individually, we would get like 15 different log level enums. And again, I was thinking, I don't really want to hassle. I don't really want to get in an argument saying that your log level isn't as worthy as his log level. So you can really easily type the enums, and you can, for instance, type it to ubyte. And then if you just partially populate it, so you can like give the element of the enum values directly, you can leave space between the enums and then just define some couple common enums most people would agree on and have the rest between them free. So everybody basically could like implement another 100 or 200 whatnot log levels to his own using. So the screen got black. Okay, yeah. So and one of the requests was like systemd, like the new init system for Linux has this awesome way of logging and struct. It's basically database, really fancy stuff. And we really should do this. And the next post was, no, nobody cares about that. I want to have this log. And the next post was, whatever. So in order to show how you could easily adopt or easily create a logger for the systemd logging facility, which basically has this one awesome C function, which isn't really awesome, which is, as you can see, just takes a string and then whatever. And actually the first string doesn't really matter, it just takes whatever in system log kind of way. So in order to create a logger for this, you would basically write this code, and that's it. You're done. You would link to the library and yeah, be done with it. And whenever you need more or want to have more of the predefined fields of systemd logged, just add them and be happy. So in this, basically, the implementation for this log would look pretty similar. But again, I can't really be sure of what you want, and I can't really try to figure out what you want, because sometimes you just wouldn't say what you want and then just complain that it's not there. And I would like, yeah, why didn't you complain earlier? And why do you vote no in the review process? You didn't help. So, yeah. I'm ahead of time. So currently the pull request is open, and most of the time passes the auto tester, which is fine. But also, in order to get using it a bit easier, I put it on DAP. It's just the name is logger for the project. Just pull it in and use it. And whenever you have a question, please write me. I mean, currently I'm in a stage where I have to like ramp up the documentation. But what I really need is people telling me what is wrong and what they want. Like what they want in a general way, not that they want whatever fancy logger. But if you have like an overall feature or saying that the way the log levels interact with or the global log levels interact with the local log levels isn't really as good, please tell me stuff about that. So 30 seconds for questions.
Questions, anyone? Right, let me make a comment. He's the third person to try to push this molasses uphill on a cold day. Well, he has something going for him, what Germans call, I'm going to mess this up, Deutsche Gründlichkeit, which could be translated as German thoroughness. He's a very thorough man, and I'm confident he can actually pull it.
Thanks.
Thanks, Robert. All right. Oh, what are we waiting for? Okay, we are done with the lightning talks, and we're going to meet again in 5 minutes for the last 2 talks of this conference.